one of the main things we do in geometry is prove why we know things are true. So the beginning of chapter 4, we start with some different reasons why we've done things in the past, and we kind of show you using some of your algebra rules that proofs are really something you've done already. You always knew why you did something. It's just in geometry we make sure you actually state it out. So a couple of the properties that we need to begin with do deal mostly with algebra things that we've done. So, for instance, the addition property. If in the beginning we know that A is equal to B, then we know that if you add the same thing to both sides, we still are equal. So I can do A plus C equals B plus C. So we start out with two equal things. If we add the same thing to both sides of the equation, it's still equal. It's how you solved basic equations. We also did the same thing with subtraction. If A minus C, or if A equals B, then A minus C equals B minus C. You subtract the same thing from both sides. We have multiplication property. We can multiply the same thing on both sides. So A times C equals B times C. All of these, again, are prefaced with the fact that A is equal to B to begin with. So we can add the same thing to both sides, subtract the same thing from both sides, or multiply the same thing on both sides. And last but not least, we can divide the same thing on both sides, as long as what we're dividing by isn't 0, because we can't divide by 0. So if A equals B, then A over C equals B over C when C is not 0. We divide by the same thing on both sides. And the last thing we know is if A equals B, then we can put B in place of A in any expression we want to. We can substitute it. So B can replace A in any expression. So those are our properties of equality: the addition property, subtraction property, multiplication property, division property, and substitution property. All of them you've used at some point in algebra. You've also used the next one, the distribution property. And for this one, A is not equal to B. This is a totally separate problem. When we distribute, we take the number that is outside the parentheses waiting to be multiplied, and we multiply it to all the terms on the inside. So we know that A times B is equal to, A times B plus A times C is the same thing as A times in parentheses B plus C. So we just multiply the number on the outside into the parenthesis. We also do something in algebra called adding like terms. When we take a 2x plus a 3x, we get 5x. Because we know that that x makes them like terms. And so we can take the 2 of the first group of x and the 3 of the second group of the x and say we have 5 groups of x total. So those are all properties of equality. In geometry, we also have some called properties of congruence. The first property of congruence is the reflexive property. In the reflexive property, we're basically saying something is congruent to itself. So we've got segment AB is congruent to segment AB. Or angle A is congruent to angle A. Why are they congruent? Well, because they're the same segment or they're the same angle, which sounds super silly right now. But when you get into proofs and some of our pictures are overlapping on each other, we're going to have the same segment in multiple pictures. Or we'll have the same angle in 2 different triangles. So we have to have a reason for why we can say that it's the same in both triangles, and it's because it's the same angle or the same segment. So that's reflexive, kind of like looking in the mirror. Your reflection is exactly the same. You also have symmetric, and that tells me that if A is congruent to AB is congruent to CD, then CD is congruent to AB. Or same thing for angles. If angle A is congruent to angle B, then angle B is congruent to angle A. So essentially it's okay to switch things around a congruent sign, just like it's okay to switch them around an equal sign. And then last but not least is your transitive property, and that's if segment AB is congruent to segment CD and segment CD is congruent to segment EF. We can kind of look at that CD being in the middle of both of these and say, well, it's the same as AB and it's the same as EF, so then AB must be the same as EF. And the same thing with angles. So if segment AB is congruent to segment CD and segment CD is congruent to segment EF, then segment AB is congruent to segment EF. Or if angle A is congruent to angle B and angle B is congruent to angle C, then B is the same in both of them. So angle A is congruent to angle C. So those are all our basic properties, the properties of equality and the properties of congruence. What you're going to do now is name the property for each one of the next problems. So the first one tells me that angle K is congruent to angle K. Go ahead and pick the right property. All right, hopefully you picked reflexive because it is the same angle, so it's the same as itself. Then we have 2x minus 8 is equal to 10. Then 2x is equal to 18. That's the one below it, letter B. Go ahead and pick the right property for that. Hopefully you're doing addition because you had to add 8 to both sides to get that to 2x equals 18. Because the 8 on the left-hand side, if you add 8 to negative 8, you get 0, so you just have 2x on that side, and if we add 8 to 10 on the right, we get the 18. All right, then we're on segment RS is congruent to segment TW, and segment TW is congruent to segment PQ, then segment RS is congruent to segment PQ. Pick the correct property. There's actually two properties you could have said here. First, we could have said transitive, but I also believe that's substitution because you are putting PQ in place of what it's equal to. You are putting it in place of the TW. Transitive is a very special setup. It has to be RS congruent to TW and TW congruent to PQ, so then we can slap it together and say RS is congruent to PQ. So this whole three-way statement has to happen. The two pieces and then the third one combining them. But substitution, you could do that one pretty much anytime. So I usually pick substitution in this case, but it is a transitive property, so transitive would be correct. But I like to realize that I'm actually putting PQ in place of TW because it's equal, so it's a substitution problem. Last but not least, angle A is congruent to angle B, then angle B is congruent to angle A. Pick your property. And hopefully you pick symmetric because they are mirror images of each other. All right, when you come into class next, we will be continuing on with these notes.